Hello everybody and welcome to this video. In today's video we are going to discuss about while loops in R programming language. So here we are going to discuss while loops. Before we discussed about the for loops. However, while loops are going to be... Hello everybody and welcome to this video. In today's video we are going to talk about vectors in R. First of all, we're going to learn how to create a numeric vector. So here is my vector called numvec. And in order to create that, I have the C, and inside parentheses, I have the elements. So 1, 3, 5, 7, and 9. These are the elements that I want to be assigned to my vector that is called numvec. And because these are all numeric values, we call it a numeric vector. Then I print this message, numeric vector, and I print the numvec vector. So when I run the code, I see this part in the output. So numeric vector, the message is being shown, and the numbers that we assign to our numeric vector is also being shown in the output. Then we would like to create a character vector. So this is my character vector. So this is called char_vec, and then here I have 3 strings that are being separated by a comma. So apple, banana, and cherry. Note that when we are having elements that are strings in a vector, we need to put quotes there. So these are the quotes that inside which we write down our strings. So cherry, banana, and apple are assigned to char_vec. We print the character vector, and then we print the char_vec in the output. So the character vector, this message is being shown here, and then we are having apple, banana, and cherry being assigned, being printed in the output as we assigned them initially. We are having another type of vector that is called logical vector, and in which we are going to have Boolean values there. So either true or false. So true, false, true, false, true, true. So true, false, true, true. These 4 elements are assigned to our logical vector. So we show this message, we print this message, logical vector, and then we print the log_vec. And in the output, we are having a logical vector. This message is being shown, and then the values that we assigned, these are the Boolean values, true, false, true, true. All of them are being printed in the output. Then we would like to create a sequence vector in R. In order to create a sequence vector, simply we are having the starting point and ending point. They are being separated by a colon here. So starting from 1, ending at 10, we are going to assign all these numbers from 1 to 10 to a sequence vector here. So we print this message sequence vector, and then we print the sec_vec in the output. So looking at the output, we are having the sequence vector, and we are having from number 1 to 10. If we want to have from 1 to 20, simply I write down 1 to 20 here, okay? And finally, when we would like to have a vector with repetition function, simply we can have a vector like this one. Let's see in the output. So 1, 2, 1, 2, and 1, 2. So the values that are 1 and 2 being assigned to this vector 3 times. In order to do that, we can write down 1, 2, 1, 2, 1, 2. Okay, but an easier method is to use the rep function. Then we would like to have 2 elements in the parentheses. Firstly, we're going to have what are the numbers that we want to be repeated, 1 and 2. Okay, so these are the 2 elements that we want to be repeated. And then separating it by a comma from the second part of the parentheses, how many times we would like it to be repeated. So 3 times. I would like these values 1 and 2 being repeated 3 times. Okay, so this is why we are having 1, 2, 1, 2, and 1, 2. So all of this is assigned to a rep vector, and then we print it in the output. If I want to 1, 2 to be repeated 5 times, I assign 5 2 times, and I run the code one more time. So we see that here we are having 1, 2, 1 2 1 2 1 2 and 1 2. So 5 times it is being repeated. And instead of 1 and 2, if I want to have 1 2 and 3 and I run the code one more time, I see 1 2 3 is being repeated 5 times. So 1 2 3, you see here, sorry. So 1 2 3 1 2 3 1 2 3 1 2 3 and 1 2 3. So this is how actually we can have different types of vector in R. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to learn how to perform some mathematical operations in vectors in R programming language. So now I would like to declare two vectors, vec1 and vec2. The first one has these 4 elements, 1 2 3 and 4, and the second one has these 4 elements, 5 6 7 and 8. Now I would like to perform the first math operation, which is the element-wise addition. In order to do that, firstly I print this message, vector addition. Then simply I print vec1 plus vec2. So looking at the output, we are having vector addition, and this is the output that we see here, 6, 8, 10, and 12. But how do we calculate this? So the first element, which is 6, is the addition of the first element of the first vector and the first element of the second vector. So 1 plus 5, it's 6. Then we are having 2 plus 6, which is 8. Then we are having 3 plus 7, which is 10. Then we are having 4 plus 8, which is 12, that we see here in the output. So this is the element-wise addition. Then we can have the element-wise multiplication. And we are firstly printing this message, vector multiplication, and then we are having vec1 multiplied by vec2. So we see that 1 multiplied by 5, it's 5. 2 multiplied by 6, it's 12. 3 multiplied by 7, it's 21. And 4 multiplied by 8, it's 32. Then we would like to have the scalar operations, meaning that I would like to add a number to each element of my vector. Okay, so here I would like to have number 5 being added to each element of the vector 1. Okay, so this is the vector 1. Doing so, I have vec1 plus 5. We can, if we want to add number 10, we can write down number 10 here. So simply we write down 1 plus 5, it will be 6. 2 plus 5, it will be 7. 3 plus 5, it will be 8. And 4 plus 5, it will be 9, as we see here in the output. So this is the scalar operation. And finally, we would like to have the dot product of two vectors, meaning that I would like to have the multiplication of 1 plus 1 and 5. So I would like to multiply 1 by 5 plus 2 by 6 plus 3 by 7 plus 4 by 8. Okay. So it means that I would like to have like the vector multiplication, but all the numbers, they must be addition, meaning that, for example, I would like to have 1 multiplied by 5, okay, plus 2 multiplied by 6 plus 3 multiplied by 7 plus 4 multiplied by 8. So the output would be 6 plus 12 plus 21 plus 32. So the output would be 70. Okay, so this is the dot product of vector 1 and vector 2. Okay, for doing that, firstly we need to have the vec1 multiplied by vec2, which we calculated earlier. Why? Because we see that vec1, when it is multiplied by vec2, we are having the same numbers here. Okay, so 1 multiplied by 5, it will be 5, sorry. So we see that 5, 12, 21, and 32. So this is the multiplication of the first vector by the second vector as we are having it here. And if we calculate the sum of these numbers, we can calculate the dot product. Okay, so then after we are having the multiplication of vec1 and vec2, we are going to sum over all the elements, which are these ones. So the output will be 70, that is shown here in the output. So in this video, we learned how to perform math operations in vectors in R. So I would like to have element-wise addition, element-wise multiplication, scalar operations, and vector dot product. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to work with vectors in R. We're going to learn how to access a single element, how to access multiple elements of a vector, how to access with logical vector, and we're going to learn how to navigate indexing in vectors and how to have access for named vectors. First of all, I'm initializing my vector called vec, and these are the elements of my vector from 10 to 60. So 10, 20, 30, 40, 50, and 60. These are the elements of my vector. Now I would like to access the third element of this vector. In order to access the third element, simply I use the print function to print it in the output. Then I call the element with index 3 of the vector called a vec. Okay, so I write down the name of the vector, which is a vec, and inside the square brackets, I'm going to write down the number of the index that I'm looking for, which is the third element. If I want to have the access to the first element, I write down simply number 1 here. Okay, so I run the code. I see that third element is 30, that is being shown in the output. Then I would like to have access to multiple elements in a vector. In order to do that, we need to have the colon. Okay, for example, I would like to access elements 2 through 4. Okay, so this is the second element, third element, and the fourth element. From 2 to 4, these are the elements that I would like to have access to. In order to do that, firstly, I print this message, elements 2 through 4. Then I call the name of the vector, which is vec. Inside the square brackets, I'm going to write the starting point, which is index 2, because this is the second element. And then colon, after colon, I write down the ending point, which is index 4, because this is the fourth element that I'm looking for. Elements 2 through 4, okay? With index 2 through 4. So index 2 is the starting point and 4 is the ending point from the vector called vec. So when I run this code, it says elements 2 through 4 are 20, 30, and 40. Actually, if we're looking for elements from 1 to 4, simply I write down 1 here. Okay, and I run the code. So let me modify this part as well. So I run the code and look at it in the output. So we see that 10, 20, 30, and 40. These are the elements from indexing 1 to 4. 10, 20, 30, and 40. So index 1, index 2, index 3, and index 4. Then I would like to have access to elements with a logical vector. What do we mean by that? In order to have access to certain elements with an if condition, for example, I want to print the elements, only the elements, let's say, that are larger than or greater than 30. Okay. In order to do that, I call each element of the vector vec that is greater than 30 inside the square brackets of the vector vec. Okay, so we write down the name of the vector here. Then here I write down the name, meaning that each element in that vector must be greater than 30 to be printed. So when I run the code, I see number 40, 50, and 60. These three values are being printed in the output because these are the elements in this vector that are greater than 30. Note that it's not greater than or equal to 30. Okay, it's only greater than 30. So I'm having 40, 50, and 60 in the output. Then I would like to have the removal of one element. So I would like to exclude the first element. Okay, in order to do that, simply write down the name of the vector, which is vec, and then -1, meaning that I want to exclude the first element. In order to exclude the first element, I have 20, 30, 40, 50, and 60 being printed in the output. So vector, we write down the name of the vector, which is vec. Inside the square brackets, I have -1, meaning that the first element is being excluded and the rest of the elements are being printed here in the output. So 20, 30, 40, 50, and 60. And finally, I have a new element that is like this. So it's like a key value pair. I have three keys, A, B, and C. Each of the keys are assigned to a value that are 1, 2, and 3. So 1 is assigned to A, 2 is assigned to B, 3 is assigned to C. And these are assigned to a vector that is called a named vec. Okay, and I would like to access by name, meaning that I want to access the element, the value of the key that is B. Okay, so as I mentioned, A, B, and C, these three are the key in our vector, and 1, 2, and 3, they are their corresponding values. Okay, so I would like to know the value for the key B. Okay, in order to do that, simply in the square brackets in quotes, I write down the name of the key that I'm looking for, which is B in this case, and then I write down the name of the vector that is named vector. So when I run the code, it says that for B, we are having the value 2, which is correct. So for B, we are having the value 2. If I want to know the value of the key C, which is number 3, I write down C here. I go up, I run the code one more time. I see that the value 3 is being printed here in the output. And this is the message, access by name. So access by name, C is 3. So in this video, we learned how to have access to elements of a vector in different ways. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn about vectors function. Okay, well, let's say a vector functions. So here is my vector called vec, and these are the elements of my vector: 5, 2, 8, 1, 9, and 3. So I have 6 elements there. Firstly, I would like to perform basic statistical functions. I would like to have some calculation for basic statistical methods for my vector. So in order to do that, firstly, I would like to calculate the sum. I write down the name of the vector, which is vec, and then I put the name of this vector actually in the parentheses of the sum function. So there is a function called sum. It can help us to calculate the sum of all elements in vector vec. Okay, so then I call the sum function inside parentheses. I write down the name of the vec, and when I run the code, I see number 28 is being shown here in the output. So the sum is 28. Then, in order to calculate the mean of a vector, I simply call the mean function for the vector vec. Okay, inside the parentheses, we write down the name of a vector, and then after that, we have the call of the mean function for this vector. So this is the message that is being printed here, mean, and the mean, or let's say the average of this vector is 4.66 approximately. Then I would like to calculate the median of the vector vec. I call the median function for the vector vec. Okay, and when I look at the output, it says the median is number 4 that is shown here in the output. So median function is going to calculate the median of this vector. And then we can have the calculation of the standard deviation using the SD function for the vector vec. And it is going to calculate the standard deviation for us, 3.26 approximately. Then what if we want to have the sort function? So I would like to actually sort my vector. In order to sort my vector, the thing that we can do is to call the sort function for the vector vec. And looking at the output, we see that here was my vector 5, 2, 8, 1, 9, 3. But looking at the output, we are having 1, 2, 3, 5, 8, 9. So this is the actually sorted version of my vector that is called vec. And now, how can we reverse the sorted vector? In order to reverse it, I call again the sort function for the vector vec, but there is a second part in parentheses, inside the parentheses. I need to separate the first part, which is the call of the name of the vector vec, with a comma from the second part. And the second part is this part, decreasing equals true. This way we can firstly sort the vector and then show it in the decreasing order. Or let's say we are directly sorting the vector in the decreasing order because we are saying that decreasing true. Okay, if we want to sort it in increasing order, we call directly sort for the vector vec. In the reverse order, we can have the sort for the vector and decreasing equals true. So looking at the output, we see that this was the sorted vector. This is the reversed sorted vector, 9, 8, 5, 3, 2, 1. Okay. Now we can have the discussion over the length and unique values of a vector. We can have the vector properties, for example. Here, in order to have the calculation of the length of a vector, simply we call the length function for the vector vec, and we see that this is the length of my vector, 6. Why? Because I have 6 elements there. So 1, 2, 3, 4, 5, 6. So 6 elements are there in my vector. Okay, so this is the length of my vector. This is how we can calculate it using the length function. And finally, imagine that we are having a new vector that consists of these numbers 1, 2, 2, 3. And I would like to find only the unique numbers. So you see that 2 is being repeated 2 times. I only want the unique values. Okay, in order to have that, we need to call the unique function. And looking at the output, we see that number 1, 2, 3, these are the numbers that are unique values of the vector with these numbers 1, 2, 2, 3. Okay, so in this video, we learned about vector functions and we learned how to work with them. Namely, we learned how to use the basic statistical functions, sorting functions, and vector properties functions. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn how to manipulate a vector in R. So first of all, I am creating a vector called vec, and these are the elements of my vector. 1, 2, 3, NA, 5, and 6. So this means that I don't have any number for the fourth element of my vector called vec. Okay, so now I would like to handle this missing value. So I have a missing value in my vector here. Okay, and I want to handle it. So firstly, I print the original vector vec. So we see it here. This is the original vector. 1, 2, 3, NA, 5, 6. Okay. Then I would like to remove the missing values. In order to do that, simply I have the na.omit syntax for the vector vec. Okay. Looking at the output, we see that now the missing value is being removed from the vector. So 1, 2, 3, NA, 5, 6. Now it's 1, 2, 3, 5, 6. Okay. So now we are having na.omit to remove all the missing values of the vector vec, and all of this is in the print function to have it in the output. Now, what if I want to replace the missing values with 0? In order to do that, I call the replace function for the vector called vec, and we check to see if there is any NA or missing value in the vector vec. If so, replace it with 0. Okay, so we call the replace function for the vector vec. We check to see if there is any missing value for the vector vec. If so, replace it with 0. Okay, and all of this is inside the print function, so we see it here in the output. Now, looking at the output, replace missing values with 0. So I see 1, 2, 3, 0, 5, 6 instead of NA, I have 0, 5, 6 in the output. Okay. Now, what if I want to append a value to a vector? In order to do that, I call the append function for the vector vec. So I want to append a value to the vector called vec. And I want to append number 7 to this vector. So I call the append function for the vector called vec and to append number 7. So I print it in the output. I see that the number 7 is being appended to the vector. So 1, 2, 3, NA, 5, 6, 7. And 7 is being appended to the vector. Then how can we combine vectors? In order to combine vectors, this is my first vector called vec1. The elements are 1, 2, 3. This is the second vector called vec2, and these are the elements 4, 5, 6. I want to combine them. In order to combine them, I call the combine, or let's say C function, and I have the vec1 comma vec2. This way, I'm going to combine vector 1 and vector 2 and print them. Looking at the output, I see numbers are 1, 2, 3, 4, 5, 6. So 1, 2, 3 comes from the first vector, 4, 5, 6 comes from the second vector. And we see that here 1, 2, 3, 4, 5, 6, these numbers are being printed here in the output. And then finally, I would like to have two new vectors, short vector and long vector. So the short vector has two elements, 1 and 2. The long vector has 4 elements, 10, 20, 30, and 40. Now I would like to do vector recycling, okay? So let's see the output first. I'm having 11, 22, 31, and 42. And this is the recycled vector addition, okay? In order to do that, I call the short vector and the long vector, and I have the addition sign in between them. So I'm adding the vector, the short vector, and to the long vector. Okay, but what's happened here is that this first vector has only 2 values, but the second vector, which is the long vector, has 4 elements. Okay, so what's going to happen is that 1 is being added to 10 firstly, and 11 is being shown here. Then 2 is added to 20, so 22 is being shown here. Then again 1 is added to 30, so 31 is being shown here, and then 2 is being added to 40, so 42 is being shown here. So this is what we call a recycle vector addition. So in this video, we learned about vector manipulation. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to talk about vector creation and different vector types in R. So first of all, I would like to create an empty vector. In order to create that, I call the vector function, and then I have the length of this vector to be 5. Okay, so now I want to create a vector with 5 elements. Okay, and using this assignment operator, I'm assigning these 5 elements to the empty vector because I did not specify what the numbers are, what the elements are of this vector empty vec. It is going to be by default 0. Okay, this is why when I use the print function to print this empty vec, when I look at the output, we see that 5 zeros are being shown in the output. So if we are looking for creating an empty vector or vector with all the elements to be 0, simply we call the vector function and we are assigning the length to be whatever we want. Like if we want to have 5 elements, if we want to have 10 elements, we can modify that. But if we don't specify the elements, it is going to by default consider them to be 0. Then we would like to create vectors using the sequence function. So we call the function that is sec, or we have the name sequence. So sec stands for sequence. And in order to create my vector that is called sec1, I would like to have a vector that starts from number 1 and ends at number 10. And I would like to step in this vector to be 2. It means that the first number is number 1 with the step of 2. The second number is 3, the third number is 5, the fourth number is 7, and finally the last number is 9. So in this range, I want to create a vector and I would like to increment the value of elements by 2. Okay, so 1 plus 2 it's 3, plus 2 it's 5, plus 2 it's 7, plus 2 it's 9. This is how I create my vector using the sequence function. Also, I can have the starting point and the ending point to create a sequence vector, exactly like before. But then I tell the compiler that I would like to have 5 elements in this range. And in order to have 5 elements in that range, I need to call length.out function. So firstly, I call the sequence function, starting point and ending point. We mention them here. And then we mention how many elements do we want to have in that range. Okay. And this is all assigned to sec2. And when we print it, we see that here the starting point is 0, the ending point is 1, and we are having totally in total we are having 5 elements. So 0, 0.25, 0.5, 0.75, and number 1. So this was how we can create vectors using the sequence function. And finally, we would like to have a vector with mixed types. So in order to create a mixed type vector, we can have this C function, or combined, let's say, and then we are having these elements. So the first one is a numeric value, the second one is a string, the third one is a Boolean expression. So this is why we call it a mixed type vector. Why? Because there are different types of elements in one vector: numeric value, integer, string, and Boolean expression here. So all of this is assigned to a vector that is called mixed vec, and we are printing mixed vec in the output, and we see that these 3 elements are being shown in the output. So in this video, we learned how to create a vector of different types in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about vector operations. So in this video, firstly, we're going to create 2 vectors, and we're going to perform some arithmetic operations, and then finally we're going to talk about recycling operation with vectors in R. So first of all, I have 2 vectors being created, vector A and B. The first one contains these elements, these 3 elements, 1, 2, 3. The second one contains these elements, 4, 5, and 6. And now I would like to perform some arithmetic operations over these 2 vectors. So firstly, I would like to have A plus B. So vector A plus vector B. I would like to do that and assign it to a new vector called sum vector, and I print it here in the output. Looking at the output, this is my output, 5, 7, and 9. How do we calculate 5? So the first elements of both vectors are added to each other. So 1 plus 4, it's 5, you see here. Then we are having 7, which is 2 plus 5. Then we are having number 9 here, which is 3 plus 6. So this is the sum of 2 vectors, let's say. Or let's say to add a vector by another one. Then we are calculating the difference. So I have B minus A, and we are having this vector, 3, 3, 3. These 3 elements are there. So 4 minus 1, it's 3. 5 minus 2, it's 3. 6 minus 3, it's 3. So this is the vector that we call def vector, and we print it here in the output. Then we are having the multiplication vector, where we are having 1 multiplied by 4, it's 4. 2 multiplied by 5, it's 10. And 3 multiplied by 6, it's 18 here. Okay. And so all of this is assigned to product vector, and the product vector is being printed here in the output. Finally, we are having the vector B divided by vector A, meaning that, for example, 4 is divided by 1, so number 4 is there. 5 divided by 2, it's 2.5 is there, and 6 divided by 3, number 2 is there. So this is actually the vector, the division vector of B by A. Now, let's move on to the next topic. We would like to talk about recycling. Now I have a vector that contains 2 elements, 1 and 2. that is called C. I have the vector D. There are 4 elements, 10, 20, 30, and 40. Now I would like to have the recycled sum of these two vectors, meaning that I want to add these two numbers to these 4 numbers. How do we do that? We simply write down C plus D and assign it to a new vector, and we print it here in the output. So this is the output. But how do we calculate it? So how do we reach to 11? Firstly, the first elements are added. So 1 plus 10, it's 11. Then we are having 2 plus 20, so it's 22. So 1 plus 30, it's 31. And 2 plus 40, it's 42. So this is how the recycled sum is calculated. So the first element, second element, first element, third element, second element, fourth element. Okay, this is how it is calculated. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to talk about logical and comparison operators in R. So we're going to firstly work with comparison operators, and then we're going to combine them with logical conditions, and we're going to finally work with any and all functions. Let's get started. So this is my vector called X. And these are the elements of my vector, 5, 10, 15, and 20. So I created a vector named X, and these 4 elements are assigned to my vector X. Now I would like to make a comparison. How do we do that? For example, I would like to see if I can create a vector of all the elements of vector X that are larger than 10. But when I work with the comparison operator, it means that I will see the output in Boolean expressions. Let me put it this way. So now let me print this vector. So I created a vector called greater than 10. And what is being assigned to this vector is the following. For each element that is in the X vector, that is larger than, or let's say greater than 10, we're going to have true or false output. So let me run the code one more time. So this is the output of the greater than 10 vector. So basically what we are doing is this. We check to see the first element of the vector X. Is it greater than 10? No. So this is false. And false is assigned to the first element of this vector. Number 10, is it greater than 10? No, so it's false again. 15, is it greater than 10? It's true. 20, is it greater than 10? It's true again. So basically, I am comparing all the elements in the vector X with a scalar number that is number 10. And the output, either true or false, is assigned to a new vector called greater than 10. So this is the output as we see here. Now I am creating a new vector that is called equal to 15. In this vector, I am checking to see if elements in the vector X equals 15 or not. If yes, the answer is true. If no, the answer is false. So now let me print this vector in the output and I run the code. So when I run the code, we see false, false, true, false. So what's happening here is the following. 5, the first element of the vector X. Is it equal to 15? No, it's false. So we are having the false in the output. 10 equals 15? No. So we see false is in the output. 15 equals 15? Yes, it's true. So true is in the output. 20 equals 15? No, it's not. So we're having the false in the output. Okay. So all of these false, false, true, false are assigned to a vector that is called equal to 15. So we are creating a Boolean expression, let's say vector. A vector with full of Booleans with this condition, okay? The elements are decided based on this condition. If I change this condition, the vector will change. For example, if I check to see if X equals 20, we're going to have false, 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 and true. Why? Because neither 5, 10, or 15 equals 20. So we are having 3 false. And 20 equals 20. This is why we are having true in the output. Now, let's move on to the next part. The next part is combining logical conditions. So now, let me put it here. Okay. Now I would like to create a vector that is called logical AND. So I would like to now teach the AND operator as well. We check to see each element of the vector X if it passes both conditions at the same time. Okay, so we check to see if 5 is greater than 5 and it is less than 20. Will it pass the both conditions? So 5 is less than 20, that is true, but 5 is not greater than 5. 5 is greater than or equal to 5, but it doesn't say that. It says 5 is greater than 5. So we are not passing one condition. We are passing only this condition and not this condition. Because we are having an AND operator there, it's a rule that we need to have both conditions being passed and being respected. Otherwise, the output will be false. So we couldn't pass both conditions at the same time, so we are having false in the output. Okay. Number 10. Is it greater than 5 now? So when I run the code, 10, is it greater than 5? Yes, it's true. And is it less than 20? Yes, it's true. So both of the conditions are true, therefore the output is true. Number 15, is it greater than 5? It's true. Is it at the same time less than 20? Yes, so it's true. Number 20, is it greater than 5? It's true. And at the same time, is it less than 20? No, it's not true. Therefore, we are having an AND operator with a true and false, so the output will be false. So we are having false because one of the conditions is not passing. Now let's talk about the OR operator. So when we talk about OR operator, this is the OR operator sign that we see here in programming in R. When we're talking about the OR operator, it means that we are checking several conditions, multiple conditions, and either of them should be true. At least one of them, if it's true, the output is true. Okay. So now here I am creating a vector to check these two conditions using OR operator. We check to see if 5 equals 5, it's true. Okay. But 5 equals 20, no. But this one is true. One condition is true, therefore the output is true. Okay. So this is the difference between AND operator and OR operator. In the OR operator, if one of the conditions is true, the output is true. We don't care about the others. 10 equals 5? No. 10 equals 20? No. So the output is false. 15 equals 5? No. 15 equals 20? No. The output is false. 20 equals 5? No. 20 equals 20? Yes. So the output is true. So this is how actually we created the logical OR operator, and we're printing it here in the output. Now finally, let's talk about the any and all functions. Here we would like to create, let me just move this part to the here and change the name. So here we are having the any function. I am calling the any function for all the elements that is in the X vector, and I'm checking to see if I can find any element that is greater than 10. Yes, you can find it because these are two elements that are greater than 10. So this is why the output is true. So we check to see if we can find any elements in the vector X that is greater than 10. Yes, we are having these elements that are these two elements that are greater than 10. But if I have, for example, greater than 25 and I run the code, the output is false because there is no element in X that is greater than 25. Now let's work with the all function. All function is going to check all the elements. We call the all function to check all the elements of the vector X to see if all of the elements in the vector X is greater than 0. Is it true? Yes, because all the elements are greater than 0. Therefore, the output is also true. So this is how we can work with logical and comparison operators in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn about subsetting and filtering vectors in R. So first of all, I am creating a vector called vec, and the elements are A, B, C, D, and E. So now if I print my vector called vec and I run the code here, you will see that these elements are being shown in the output, A, B, C, D, E. So these are the elements of my vector V. Now I would like to access the first element of this vector. In order to access the first element of a vector, I can directly, like this, access the first element of the vector vec. So if I run the code now, I see that the first element, which is A, is being shown here. How? So basically, I am calling the element with index 1, which is the first element of the vector vec inside the print function. This is why we see A in the output. So if I want to access the second element, I simply write down number 2 here for the vector vec, vector that is called vec. So I run the code, I see B is in the output. So this is how we can directly access one element of a vector. But there is another way. Another way would be to call the first element of the vector that is called vec and assign it to a new vector, or let's say variable here, called first element, and then print this first element in the output. Okay, so now if I run the code, you will see that A is being shown here in the output. How? Because now I am having the call of the first element and assigning it to first element here, and then I'm printing it here in the output. If I want to have access to the, for example, third element, I write down number 3 here, run the code, and we see that C is shown here in the output. Now this is how we can access one element by position. Now if I want to have a subset of the vector, how can we do that? In order to do that, for example, I would like to have a subset from the element 2 through 4, meaning that B, C, and D, I would like to have them in a new set or in a new vector, let's say. So here I call the vector that is called a vec. In the brackets here, I have the elements index. So I want to have from index 2, or let's say from element 2 to element 4. Okay, so the starting point is 2 and the ending point is 4. Okay, so 2 to 4 of the vector vec is assigned to this subset 1. And now if I print this subset 1, so I print it here, I run the code, we see that B, C, and D, all of them are being shown here in the output as they are elements from index 2 to 4. If I want to have from 2 to 5, I run the code one more time. We see that B, C, D, and E are showing here in the output. So this is basically how we can create a subset from an existing vector. Now I am creating a new vector that is called numbers. And this vector has these elements, 10, 20, 30, 40, and 50. Now that I have these elements, I created my vector called numbers. So first of all, let me print this numbers vector. So I write down the name here, I run the code. We see that these are shown here in the output, 10, 20, 30, 40, and 50. So now that these are the elements of my vector numbers, I would like to print the numbers that are, let's say, divisible by 20. Okay. And in order to do that, I would like to create a new vector that is called even numbers. And this new vector can only hold values that are divisible by 20. Okay. So we are basically filtering our current vector. So what do we need to do? In order to do that, for all the elements of this numbers vector that are divided by 20 and the remainder of their division using the modulus operator equals to 0, meaning that that number, that element is divisible by 20. For example, 40 is this element, is divided by 20. The remainder of their division equals 0. Yes? Yes, of course. So 40 is divisible by 20. Okay. So if I want to do the same thing, 20 is going to be the same. But if we are going to divide 50 by 20, the remainder of this division, is it equal to 0? No, it's not equal to 0. Therefore, it's not a number that we are looking for to be assigned to the even numbers vector. In order to set this filtering, we are going to say for all the elements in the numbers vector that are divided by 20 and the remainder of this division equals to 0, assign them to a new vector called even numbers. So here, now I want to print even numbers. I run the code, and 20 and 40, both of them are being shown in the output. So let's do it manually. 10 divided by 20, the remainder equals 0. No, so it's not assigned. 20 divided by 20, the remainder of this division equals 0. Yes, so 20 is assigned to even numbers. 30 divided by 20, the remainder of this division equals 0. No, it's not assigned. Next, 40 is divided by 20. The remainder of this division equals 0. Yes, so 40 is assigned. 50 is divided by 20. The remainder of this division equals 0. No. Therefore, 50 is not assigned. Now that we assigned 20 and 40 to the even numbers vector, we are printing it here in the output. Okay. So let's go to the use of which function. So now here I would like to have the prints of the position vector. But firstly, let's see how we are actually creating this position vector. So we would like to set a condition, meaning that we are going to use the which function. Let me run the code. We are going to use the which function, and for the, let me remove this also. Okay. So we are going to call the which function for the elements that are in the numbers vector that we created here, okay, that are greater than 25. So basically, this which function is going to tell us which indices of the elements that are in the numbers vector have a value greater than 25. So 10, is it greater than 25? No. 20, is it greater than 25? No. 30, is it greater than 25? Yes. So which, what is the index of this 30? It's number 3. So 3 is assigned to the positions. Okay. So using the which function, we are going to find which element has a value, for example, greater than 25. We are going to return its index. So 40, is it greater than 25? Yes. Its index is 4 because this is the fourth element, is assigned to position. 50, greater than 25. Yes, so 5 is assigned to the position. When we print the positions in the output, we see that 3, 4, and 5, all of them are being shown here in the output. So this is basically how we can have the use of which functions. Now let's do the negative indexing. So now if I run the code, we see that here the first element is not there anymore because my vector called vec had values from A to E, but in the output we are having B to E. So the first element, which is A, is not shown there. So what's wrong there? What's happening? In order to exclude elements, we can use the negative indexing. Okay, so I call the vector called vec with the index -1, meaning that it's going to exclude the first element. The element with index 1 is going to be excluded using the -1 index there, and is assigned to these without first, and without first is being shown here in the output. So if I run the code now you see that we are having -2, and instead of having the exclusion of the first element, which was A, we are having now the exclusion of the second element, which is B. So we are having A, C, D, E in the output. So this is how we can work with subsetting and filtering vectors in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about named vectors. We're going to learn about assign names, access by name, modify names, and remove names. So first of all, I am creating my vector that is including names as well. So the name of my vector is named vec, and these are the elements. Apple equals 10, banana equals 20, and cherry equals 15. You can see it as a key value pair. Okay, so these are my keys: apple, banana, and cherry, and values are 10, 20, and 15. Okay, so I have 3 elements there, and there are 3 key value pairs. Actually, all of them are assigned to a vector called named vector. So if I print it here in the output and I run the code one more time, you see this in the output. So apple 10, banana 20, and cherry 15. Okay, this is how we can access my vector. Now I would like to have access to one element of this vector based on its name. For example, I would like to access the value that is assigned to the key banana. In order to do that, simply we write down the name of the vector, which is named vec, and here I write down the name of the key that I'm looking for its value. Okay, all of this is assigned to banana count, and I use the print function to print the banana count here in the output. So if I run the code now, we see that banana is 20. So banana, this is what we were looking for, and its corresponding value, which is 20, is being shown here in the output. Next, we would like to modify names there. Okay, now I am having the named vec, which is the name of my vector with assigned names. Okay, and I call the names function for that to modify its key names. Okay, to modify apple, banana, and cherry. Now on the right hand side, I am assigning the new names for this vector. So let me print the vector now, named vec. I run the code here, and we see that A, B, C, 10, 20, and 15. All of them are shown here in the output. So named vector was having 3 key names: apple, banana, and cherry. Here I call the names function for the named vec, and on the right hand side I'm assigning the new names, and these new names are now shown here in the output. Okay, now I would like to remove the names. How can we do that? In order to remove the names, let me run the code here, and we see that if I run the code now, we see that only values are shown here in the output. How can we remove the names? So I would like to remove the name for the named vector. So I call the onName function for the named vector and assigning it to unnamed vec. Okay, so this is going to remove the names from the named vector and assigning it to a new vector called unnamed vec. and we are printing unnamed vec in the output that are 10, 20, and 50. So in this video, we worked with named vectors. Thanks for watching. Hey everybody, and welcome back. In today's video, we would like to perform some mathematical operations using vectors. In this video, we learn how to declare two vectors and how to perform mathematical operations like element-wise addition, subtraction, multiplication, or division between these two vectors and assign them to a new vector called result. So here is my first vector that is called A, and these are the elements of the vector A. So 1, 2, 3 is assigned to a vector called A. Numbers 10, 20, and 30 are assigned to a vector called B, and then these two vectors that are now declared A and B, I would like to have the element-wise addition of them, okay? And the element-wise addition means that the first element of the vector A is going to be added to the first element of vector B. The second element of vector A is added to the second element of vector B. The third element of vector A is going to be assigned to the third element of vector B, okay? And all of them are going to be assigned to a vector called result. Then we print the result vector, which is 11, 22, and 33. So 11 comes from where? So 1 plus 10, it's 11, is the first element of the result vector. Then we are having 2 plus 20, which is 22. So 2 plus 20 is 22, the second element, and 3 plus 30, it will be 33. So it's the third element. So this is how basically we can have the element-wise addition of two vectors. But if we, instead of having the plus, if we are having the negative sign, we're going to have the element-wise subtraction. So if I run the code one more time, we see that 1 minus 10, it will be negative 9, 2 minus 20, negative 18, and 3 minus 30, it's negative 27. So it's element-wise subtraction. Then we can have the element-wise multiplication here. So when I run the code now, we are going to have 10, 40, and 90. So 1 multiplied by 10, it's 10. 2 multiplied by 20, it's 40. And 3 multiplied by 30, it's 90. And finally, if we want to have the element-wise division, we simply have A divided by B there. So we run the code and we see that all the elements are going to be 0.1. Okay, so this is basically how we can have element-wise mathematical operations. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to work with another example of for loops. So first of all, I have a vector of names that is called C. Okay, so C is a vector of names, and you see that inside parentheses, I have three names: Alice, Bob, and Charlie. Okay, and this vector of names is being assigned to a variable called names. So names now is a vector of names, and it has three. Hello everybody, and welcome to this video. In today's video, we are willing to write a program that modifies one element of a vector. So first of all, we are having our vector called scores. Then these are the elements of this vector: 10, 20, and 30 that are assigned to a vector called scores. Okay, so first of all, I'm going to print scores vector. So when I run this code now, you see 10, 20, and 30 in the output, exactly the elements that are assigned to scores vector. Okay, but I would like to modify the first element of this scores, let's say, vector. So the first element has the numeric, is actually a numeric integer that is 10. Now I would like to modify it and put it to be 15. In order to do that, we simply write down the index of the element in the scores vector on the left hand side, and then number 15, for example, on the right hand side. So it's going to change the first element in the scores vector, and 15 is going to be assigned to the first element of the scores vector, and which is now number 10. Okay, so when we do that, and then if I print the scores vector one more time, we see that now it has 15, 20, and 30 instead of 10, 20, and 30. Okay, so basically this is how we can modify an element of a vector. But what if I want to modify the second element? So now I would like to modify the second element, and I want the second element to be, for example, 33. So now I run the code. I see that the first element remains unchanged, and the second element is now 33. The third element also remained unchanged. So we write down number 33 on the right hand side. It is going to be assigned to the second element of the scores vector, and when we reprint the vector one more time, we see that the modified version is out there. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to have another example of for loops in R programming language. So first of all, we would like to define a vector of names, and then we are going to print the names that are inside that vector one by one. So here I have the vector of names being initialized. So the name of my vector is names, and here we are having 3 names in our vector: Alice, Bob, and Charlie. Okay, and we are using the C function to combine values into a vector. So these are my values that are being combined into a vector, and they are being assigned using the assignment operator to names. Okay, this is the name of my variable, name of my vector. So now I would like to print the names one by one. Alice, I would like to print it. I would like to print Bob, and I would like to print Charlie. Okay, in order to do that, of course we can do it manually, but we don't want to do that. It's not efficient. So we need to have a for loop. So we define a for loop for each name in names. So names is the name of my vector, and name is my iterating variable. It could be I, for example. Let me just put I here, it's easier. So this is my iterating variable. For each I in the names vector, in each iteration, okay, print this. Okay, and what is going to print is going to print hello. And then in the first iteration, I equals Alice, the first name in the names vector. So hello Alice. In the next iteration, hello Bob. In the next iteration, hello Charlie. So you see that here we have all of them in the output: hello Alice, hello Bob, and hello Charlie. Okay, but what does this paste function do here? So if I remove the paste function, it's not going to work, and we're going to see errors. Why? Because we are having 2 strings here. So this is the first string, and this is the second string, and we would like to join them into one string. As you see here, a hello Alice is being printed as one string, but here they are separated. So I use the paste function to join multiple strings or variables together into one string. Okay, and then we have the print function to print them in the output. So hello Alice, hello Bob, and hello Charlie, they are being printed in the output. So in this video, we learned how to define a vector of names, and we use the C function to combine values into a vector. And then we had a for loop for each I in the names vector. We are going to, in each iteration, print the elements of that vector. So I in the first iteration equals Alice, so we are going to have hello Alice. In the second iteration, I equals Bob, so we are going to have hello Bob. In the last iteration, I equals Charlie, so we are going to have hello Charlie. Thank you for watching.